Ben Jacobson proposes in 1990 that a fast retransmit should have a fast recovery mechanism also. That is, the TCP is required to generate an immediate acknowledgement, obviously, on receiving triple duplicate acknowledgements when an out of segment is received. To inform the sender that a segment number, what segment number is expected. By the way, it's important for us to understand that why a receiver will be sending triple duplicate acknowledgement, and there can be following reasons behind this. Number one is maybe a segment has lost, or maybe the segments are reordered, or maybe the data is still flowing between the two ends. Okay, so these are the possible reasons that a receiver will be generating triple duplicate acknowledgements. So now, if a triple duplicate acknowledgement is received, means three acknowledgements are received in a row. So this means we will definitely enter into a fast timeout, a fast retransmit mode, and will not wait for the timeout. And but we'll do congestion avoidance, but not the slow start. So this means we will not go back to one again, where this congestion window size is one maximum segment size, and then again we increase it exponentially, right? So we will not go in this slow start phase, and we'll try to do a catch up, right? We will try to increase the congestion window size so that we can efficiently utilize the network bandwidth. And this was proposed in a variant of TCP known as TCP Reno. The picture that we have in front of us is representing TCP Reno. Okay, so in TCP Reno, this phase is the same, right? So this phase is slow start. So remember, we start with maximum segment size, congestion window size having or equal to one maximum segment size, and upon receiving acknowledgement, we increase the congestion window size to 2, and upon receiving cumulative acknowledgements, we receive it to 4, and then 8, and then 16. So this increase is exponential, right? And belongs to, and it represents the slow start phase. And then we have this now when the congestion window size is equal or greater than the slow start threshold, which is 16 in this case. Now we will increase it linearly, right? And now we are increasing it linearly from 16 to 17, 18, 19, right? And 20. And let's assume that now at 20 we receive triple duplicate acknowledgement. So these are the triple duplicate acknowledgements. Acknowledgement number 1, duplicate acknowledgement number 2, duplicate acknowledgement number 3. So now we'll do the multiplicative decrease. So this step here is the multiplicative decrease. That is, we will divide the congestion window, which was what? 20 by 2, and the next, and by doing so we'll get the slow start threshold value, which is obviously 10 in this case. But we do not enter into this slow start. And what was happening previously? We were in this slow start. We were sending segment number 1, and then segment number 2, and then segment number 4, and then segment number 8, and then segment number 10. Now this is not happening here. Okay. Why? Because this is fast recovery. Now this mechanism is called fast recovery. How? Because we do not enter into this slow start. Now, what is the congestion window? The next question is. So the congestion window is equal to the threshold, the SS threshold, which is slow start threshold, 10 plus 3 duplicate acknowledgement. This means the congestion window in this case would be congestion window would be threshold, which is 10 plus 3 duplicate acknowledgement, 3, which is 13. So 10, 11, 12, and 13. So this means we'll be sending how many number of segments? 13 segments, waiting for a cumulative acknowledgement. And upon receiving the cumulative acknowledgement, we will increase it linearly, and we'll keep doing this. We will keep performing this congestion avoidance phase until we receive an acknowledgement for the new data. This is very important point for you to understand, right? So we'll keep doing this until an acknowledgement for the new data has been received. If it is not received, we'll keep doing it. If and let's assume that at this point we receive an acknowledged or we have received an acknowledgement for a new data or new segment. Now we'll come back to this threshold, slow start threshold. And what was the slow start threshold? The slow start threshold was and is 10 in this case, and then we'll again have this linear increase, and we'll try to probe the network performance. Okay. So by the way, this here is representing what? Fast recovery phase, right? So this was proposed by when Jacobson and is part of TCP Reno. But there's a problem with this approach. It's good to handle single segment loss. Right? If we have this TCP Reno is not effective in case of multiple segment losses. So if we have multiple segment losses, probably this won't work. And in case of multiple segment losses, we make use of TCP Reno, new Reno. The solution to this problem is TCP new Reno, right?